just very slightly warm. That's perfectly okay. So now the question is, with this amount of preload, how much run out have we got? And you know what? I'm going to do that tomorrow because I need a drink and a rest. Checking it on the tool and turning the spindle by hand. 1.8. About 1.8. Well, that is to say 0.018 millimetres. It's always less when I turn the spindle by hand than if I turn the... Well, we can demonstrate that. That's 0.03 when powered, rather than moving it by hand. Going back to my Range Rover for a moment, this is an axle differential from a Range Rover, and this pinion gear is supported on a taper roller bearing, which is pulled back through the housing by this nut here, securing it to this flange. And there's a shim here which sets the preload on that bearing. So the question is, how do you get the shims right? Well, the idea that Land Rover came up with is that you do this nut up to the rather high torque of 120 foot-pounds, and then you wrap a piece of string round this flange, as shown here, and pull it away with a spring balance and measure the force required to rotate this drive flange and the pinion. And if it's within this rather wide range of 2.7 to 11.3 kilograms, you're okay. If not, you take it apart, change the shims and repeat until you get the right answer. Now, I thought, as a physicist who isn't an engineer, that that was quite a good way of assessing objectively what the preload was. You're obviously not measuring it directly, but you're measuring it indirectly. But at least it's objective. Well, on its present setting, I would say it was very, very light. This is the most sensitive spring balance I've got. It measures no more than 0.2 kilograms, I'd say. So that's pretty loose. I'm just going to mark this. In case I lose my position. So that mark is lining up with the edge of this spline. Right. So whereas before that line on the collar was lined up with the left-hand edge of this spline, now it is halfway between one spline and another. I don't see any noticeable difference. Maybe it's 0.3 now. On the kilogram scale. Only very slightly warm. That's absolutely fine. Well, that's still 0.02 millimetres, which is 0.8 thou. That's still too much, in my humble opinion. Right. Well, the scratch is midway across this spline, and I'm going to move it until it comes up to that spline, the left hand side of that spline, I hope. A bit more than that, please. I must get a better pin spanner for this. Right, that's just up to the right hand edge of that spline now. Well, now tightening that collar is beginning to bite, because whereas before it was 0.4 kilograms, I think it was, or was it 0.6? But anyway, now it is about 2, isn't it? So that is too tight. We want some compromise between 2 kilograms and 0.6. How about 1.2? Right, so we've got to come, we were halfway between these two splines before, so we've got to come back a quarter of this distance, about there perhaps. Just bashing the thing on the top. Well, let's try that. Right, so this is about 0.8, I would say. What do you think? 0.8 or 0.9? That's quite good in terms of compromise between the two that we had before. So we'll try that. Well, warmer, but I think it's well okay. Not more than 0.015. Not sure what that funny cricket-like sound is there. Seems to be coming from up there, but might be in the motor. It's not this sensor. I could do with a smoother and more regular sound, but we seem to be all right on run out and all right on heating. So I think I shall call that done. So when I got to measuring it properly, the first two trials were too loose. The third trial was a bit too tight, and the fourth trial came out about right, which suggests that one should aim for a spring force of about 1 kilogram, which corresponds to a torque of 194 Newton millimeters. When I started this job, I'd never seen inside the quill, so I didn't know what was there. Now that I have, I see that what you've got is a steel quill, a steel spindle, and steel bearings and some grease and nothing else. So probably the quill doesn't mind being heated up a fair amount, and maybe I was bothering about something that wasn't really important. The grease that I've installed in the quill now is rated up to 110 degrees centigrade. So, you know, if the quill got to 80 degrees C, it probably wouldn't matter. In any case, I've come to the conclusion that you know, if there's a choice of having a cool quill with a lot of run out or having a hotter quill with little run out, I'd rather have the small amount of run out. So that's where we are on that, and I shall be glad to be able to get back to actually using the mill for something useful next week. Thanks for watching.